Page number 65. Here we go. Falsely blaming yourself. I have studied people making errors, sometimes serious ones, with mechanical devices, light switches, and fuses, computer operating system and word processor, even airplanes and nuclear power plants. Sorry. Invariably, people feel guilty and either try to hide the error or blame themselves for stupidity or clumsiness. I often have difficulty getting permission to watch. Nobody likes to be observed performing badly. I point out that the design is faulty and that others make the same error. Yet, if the problem appears simple or trivial, people still blame themselves. It is almost as if they take perverse pride in thinking of themselves as mechanically incompetent. I once was asked by a large computer company to evaluate a brand new product. I spent a day learning to use it and trying it out on various problems. In using the keyboard to enter the data, it was necessary to differentiate between the return key and enter key. The If the wrong key was pressed, the last few minutes work was irrevocably lost. I point out this problem to the designer, explaining that I myself had made the error frequently and that my analysis indicate that this was very likely to be the frequent error among users. The designer's first response was, "Why did you make the error? Didn't you read the manual?" He proceeded to explain the different key function of the two key. Yes, I explained. I understand the two key. I simply confuse them. They have similar functions, are located in similar locations on the keyboard. As a skill typist, I often hit return automatically without thought. Certainly, others have had similar problems. Nope, said the designer. He claimed that I was the only person who had ever complained, and the company's employee had been using the system for many months. I was skeptical, so we went together to some of the employees and asked them whether they had ever hit the return key when they should have entered, and did they ever lose their work as a result. Oh, yes, they said, we do that a lot. Well, how come nobody ever said anything about it? After all, they were encouraged to report all problems with the system. The reason was simple: when the system stopped working or did something strange, they dutifully reported it as a problem, but when they made the return versus enter error, they blamed themselves. After all, they had been told what to do. They had simply erred. The idea that a person is at fault when something goes wrong is deeply entrenched in society. That's why we blame others and even ourselves. Unfortunately, the idea that a person is at fault is embedded in the legal system. When major incidents occur, official court of inquiry are set up to assess the blame. More and more often, the blame is attributed to human error. The person involved can be fined, punished, or fired. Maybe training procedures are revised. The law rests comfortably. But in my experience, human error usually is a result of a poor design. It should be called system error. Humans err continually. It is an intrinsic part of our nature. System design should take this into account. Pinning the blame on a person may be a comfortable way to proceed, but why was the system ever designed so that a single act by a single person could cause calamity? Worse, blaming the person without fixing the root underlying cause does not fix the problem. The same error is likely to be repeated by someone else. I return to the topic of human error in chapter 5. Of course, people do make errors. Complex devices will always require some instructions, and someone using them without instructions should expect to make error and to be confused. But designers should take special pain to make errors as cost free as possible. Here is my credo about error. Eliminating the term human error. Instead, talk about communication and interaction. What we call an error is usually bad communication or interaction. When people collaborate with one another, the word error is never used to characterize another person's utterance. That's because each person is trying to understand and respond to the other. And when something is not understood or seem inappropriate, it is questioned, clarified, and collaboration continues. Why can't the interaction between a person and a machine be though as a collaboration? Machines are not people. They can't communicate and understand the same way we do. This means that their designers have a special obligation to ensure that the behavior of machine is understandable to the people who interact with them. True collaboration may require each party to make some effort to accommodate and understand the other. When we collaborate with machine, it is people who must do all the accommodation. Why should not the machine be more friendly? The machine should accept normal human behavior, but just as people often subconsciously assesses the accuracy of things being said, machines should judge the quality of the information given in this case, to help its operator avoid grievous error because of simple slip discussed in chapter 5. Today we insist that people perform abnormally to adapt themselves to peculiar demand of machines, which includes always giving precise, accurate information. Humans are particularly bad at this, yet when they fail to meet the arbitrary, inhuman requirement of machine. We call it human error. No, it's a design error. Designer should strive to minimize the chances of inappropriate action in the first place by using affordance, signifier, good mapping, and constraint to guide the action. If a person performs an inappropriate action, the design should maximize the chance that this can be discovered and then rectified. This requires good, intelligible feedback coupled with a simple, clear conceptual model. When people understand what has happened, what state the system is in, and what the most appropriate set of action is, they can perform their activity more effectively. People are not machines. Machines don't have to deal with continual interruption. People are subjected to continual interruption. As a result, we are often bouncing back and forth between tasks, having to recover our place, what we were doing, and what we were thinking when we return to a previous task. No wonder we sometimes forget our place when we return to the original task, either skipping or repeating a step, or imprecisely retaining the information we were about to enter. Our strength are in our flexibility and creativity in coming up with solution to novel problems. We are creative and imaginative, not mechanical and precise. Machines are required precision and accuracy, people don't. And we are particularly bad at providing precise and accurate input. So why don't we always require to do so? Why are we always required to do so? Why do we put the requirements of the machine above those of people? When people interact with machines, things always will not always go smoothly. This is to be expected. So designers should anticipate this. It is easy to design device that will work when everything goes as planned. The hard and necessary part of design is to make things work well even when things do not go as planned. How technology can accommodate human behavior. In the past, cost prevented many manufacturers from providing useful feedback that would assist people in forming accurate conceptual models. The cost of color display, large and flexible enough to provide the required information, was prohibited for small and inexpensive device. But as the cost of the sensor and display has dropped, it is now possible to do a lot more. Thanks to display screens, telephones are much easier to use than ever before. So my extensive criticism of phone found in the earlier edition of this book have been removed. I look forward to great improvement in all our devices now that the importance of these design principles are becoming recognized, and the enhanced quality and lower cost of the display makes it possible to implement the ideas. Providing a conceptual model for a home thermostat. My thermostat, for example, designed by Nest Lab, has a colorful display that is normally off, turning on only when it senses that I am nearby. Then it provides me with the current temperature of the room, the temperature is to which it is set, and whether it is heating or cooling the information the room. The background color changes from black when it is neither heating nor cool, to orange while heating, or to blue while cooling. It learns my daily pattern, so it changes temperature automatically, lowering it at bedtime, raising it again in the morning, and going into away mode when it detects that nobody is at home. All the time it explains what it is doing. Thus, when it has to change the room temperature substantially, either because someone has entered a manual change, or because it has decided that it is now time to switch, it gives a prediction. Now 75 will be 72 in 20 minutes. In addition, Nest can connect wirelessly to smart devices that allows for remote operation of thermostat, and also for larger screens to provide a detailed analysis of its performance, aiding the home occupants development of a conceptual model both of Nest and also of the home's in energy consumption. Is Nest perfect? No, but it marks improvement in collaborative interaction of people and everyday thing. Many machines are programmed to be very fussy about the form of input they require, where the fussiness is not a requirement of the machine but due to the lack of consideration of people in the design of software. In other words, inappropriate programming. Consider these examples. Many of us spend hours filling out forms on computers, form that requires name, date, addresses, telephone numbers, monetary sums, and other information is fixed rigid format. Worse, often we are not even told the correct format until we get it wrong. Why not figure out the variety of way a person might fill out a form and accommodate all of them? Some companies have done excellent job at this, so let us celebrate their action. Consider Microsoft Calendar's program. Here it is possible to specify date any way we like: November 23, 2015, 23 November 15, or 11/23/15. It even accepts phrases such as week from Thursday, tomorrow, a week from tomorrow, or yesterday. Same with time. You can enter the time in any way you want: 3:45 p.m., 15:35, an hour, 2 and 1/2 hour. Same with telephone number: 1 to start with a plus sign, to indicate the code of international dialing. No problem. No problem. Like to separate the number field with spaces, dashes, parentheses, slashes, period. No problem, as long as the program can decipher the date, time, or telephone number into a legal format, it is accepted. I hope the team that worked on this got bonus and promotion. Although I single out Microsoft for being the pioneer in accepting a wide variety of format, it is now becoming a standard practice. By the time you read this, I would hope that every program would permit any intelligible format for names, dates, phone number, street address, and so on, transforming whatever is entered into whatever form the internal programming needs. But I predict that even if the 22nd century, there will still be forms that require precision, accurate, but arbitrary format for no reason except the laziness of the programming team. Perhaps in the year that passes between this book publication and when you are reading this, great improvement will have been made. If we are all lucky, this section will be badly out of date. I hope so. Yep, that's page number 70, and we'll continue this next day. Thank you.